Hello everyone. I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture, that is lecture number 5, we will briefly discuss about evolution of radio access network, that is RAN. The radio access network RAN has undergone significant evolution over the years, transforming the way we communicate and access mobile services. From its humble beginnings to the current 5G era, RAN has played a crucial role in shaping the mobile industry. First, the 1G, the first generation 1G of RAN or RAN, radio access network, introduced in the year 1980s and marked the beginning of mobile communication. Using the analog technology and frequency division multiple access. This 1G was using FDMA, frequency division multiple access. The 1G enabled basic voice services, laying the foundation for future generation. And the second generation, 2G of RAN, launched in the year 1990s, brought digital technology to mobile communications with TDMA, time division multiple access, and a global system for mobile communication system, that is GSM. 2G enabled text messaging, email, and basic data services, evolutionizing personal and professional communication. This 2G was the responsible the network we were been using mainly. There is email, text messaging, and basic data services we are used by using this 2G technology. Then we'll move on to the 3G, the third generation 3G of RAN, introduced in the year 2000 and was a significant leap forward with the universal mobile telecommunication system, that we can call it as UMTS, and wide band code division multiple access, that is WCDMA, wide band code division multiple access. 3G enabled faster data rate, that is higher data rate, and mobile internet and video calling. We were been using by using this technology, video calling, and transforming the way we access information and communicate. Next, 4G, the fourth generation, that is 4G of RAN, launched in the year 2010s, brought high-speed data rates and mobile broadband to the masses. With LTE, that is long-term evolution, LTE, and orthogonal frequency division multiple access, that we can call it as OFDM, with LTE and OFDMA, the 4G video streaming, online gaming, by making use of online gaming, and cloud computing, further blurring the lines between fixed and mobile broadband. One more time I will tell you, the fourth generation of RAN, launched in the year 2010, brought high-speed data rates and mobile broadband to the masses. With LTE, that is long-term evolution, and OFDMA, orthogonal frequency division multiple access, 4G enabled seamless video streaming, online gaming, and cloud computing, further blurring the lines between fixed and mobile broadband. Next, 5G, the fifth generation 5G of RAN, introduced in the year 2020s, and represent a quantum leap in mobile communication with the new radio NR and massive MIMO MIMO, the 5G promises ultra high speed data rates, very high speed, and low latency and massive connectivity, enabling a new era of especially this IoT, Internet of Things, mission critical communication, and immersive technologies. So, in conclusion, the evolution of RAN has been remarkable journey marked by significant technological advancement and innovations. From humble beginnings to the current 5G era, RAN has transformed the mobile industry, enabling faster data rates, lower latency, and new use cases. As we look as we look to the future, RAN will continue to play a vital role in shaping the mobile landscape. Next, we'll see how a radio access network, that is RAN, works. This is the architecture of the working condition of RAN. The radio access network RAN is a critical component of mobile communication system, enabling the user equipment. We can call it as UE, user equipment, to connect the network and access various services. The RAN works by facilitating communication between UE, that is user equipment, and the core network, and ensuring efficient, reliable data transfer. We'll see one by one. User equipment connection, UE. The first step in RAN process is the connection of user equipment, UE, user equipment, to the nearest cell tower, also known as the E node B, that we can call it as E node B or node B. This connection is established through the radio signals and allowing the user equipment to communicate with the network and access various services. Next, authentication. Once UE, that is user equipment, is connected, the next step is the authentication, where the UE verifies its identity with the RAN using credentials stored in the home subscriber server. This I was telling you in the previous lecture, home subscriber server. This secure authentication process ensures that only authorized users can access the network, preventing unauthorized access and maintaining the network security. Next, radio resource allocation. After authentication, the E node B or node B allocates radio resources such as frequency and bandwidth to the UE, user equipment, and this efficient allocation of resource ensures that the UE receives the necessary resources to maintain a high quality connection and access network services. Next, data transmission. With the resources allocated, this UE sends data to E node or node B, which then forwards the data to the SGW, that is servicing SGWC servicing gateway. This data transmission process enables the UE to communicate with the network and access various services such as voice, data, and video. One more time, I'll tell you how the data transmission has been done. With the resources allocated, the UE sends data to the E node or node B, which then forwards the data to the servicing gateway, SGW. This data transmission process, this data transmission process enables the user equipment to communicate with the network and access various services such as voice, data, and video. Next, data routing. Finally, the SGW. What is SGW? Servicing gateway routes the data to the mobility management entity, that is MME, for processing. The MME ensures seamless data transfer and mobility management, allowing the user equipment to maintain connectivity while moving between, this is very, very important, moving between cells and network. So coming to the conclusion, in summary, the RAN works by connecting user equipment to the network, authenticating users, allocating radio resources, transmitting data, and routing data processing. This complex process enables efficient and reliable mobile communication, allowing users to access various services and stay connected on the go. Next, the key advancement in RAN evolution, that is radio access network. The evolution of radio access network, RAN, has been a remarkable journey marked by significant advancement in technology, performance, and efficiency. This is very, very important to think of RAN. Each generation of RAN has brought new innovations, enabling new use cases and services that have transformed the way we communicate and access information. And the first advantage is the digitization. Digitization has been a key driver of RAN evolution, transforming analog signal processing to digital signal processing. What are the advantages of using digital signal processing that we'll see? This shift has improved signal quality, increased capacity, and enabled the user of advanced technologies like especially this is the main advantages of this digitization. Digitization has laid the foundation for high speed, high capacity networks we use today. Next advantage is multiplexing. The solution enabling multiple users to share the same frequency, that is frequency division multiple access to time division multiple access TDMA. The core division multiple access CDMA and orthogonal frequency division multiple access has significantly increased capacity and efficiency, allowing more users to access the network simultaneously. That is the main advantages of CDMA and OFDMA. Next, coming into the network architecture, the advantages. The evolution of network architecture has transformed and ran from a centralized to a distributed and cloud-based architecture. This shift has improved scalability, flexibility, and resilience, enabling network to adapt to changing traffic patterns and user demands. Cloud-based RN has also enabled greater automation, simplifying network management and operation. Next, spectral efficiency. Advances in spectral efficiency have been critical to RAN evolution, enabling more data to be transmitted over the same frequency band. This is the main advantages of the network what we are using today. Improved modulation and coding schemes have increased capacity and throughput, allowing for faster data speed and greater user satisfaction. Next, capacity and throughput. The combination of carrier aggregation, multiple input, multiple output, MIMO, the and beamforming has significantly increased capacity and throughput in RAN. These technologies have enabled a network to support more users, devices, and application, delivering faster data speeds and better user experience. Next, the main advantages of using RAN is latency reduction. Latency reduction has been a key focus area in RAN evolution. RAN evolution with the goal of reducing the latency from millisecond to microseconds. This reduction has enabled real-time communication and services such as voice over LTE. We can write it as voice over LTE. We can call it as VoLTE. Online gaming and virtual reality, which require fast and responsive networks. Next, virtualization and software-defined RAN. Virtualization and software-defined RAN has revolutionized network architecture and operation, enabling greater flexibility, scalability, and automation. This is the main advantage. These technologies have simplified network management, reduced cost, and enabled faster deployment of new services and applications. Coming into the conclusion. In conclusion, the evolution of RAN has been a remarkable journey marked by significant advancement in technology, performance, and efficiency. As we look to the future, ongoing research and development focused on 6G and beyond will continue to shape the direction of RAN evolution, enabling new use cases, services, and applications that will transform our world. So, this is the basics about RAN that we have seen from 1G, 2G, 3G, 4G, and 5G. RAN, architecture of the RAN. Then we have moved into the main advantages of RAN, what we are using now. The remaining